Hello friends, so as you welcome in this lesson, the first issue today our objective is we are going to work on explorative data analysis in pandas. So we have import pandas as PD. So we also need to import some data visualization like seaborn and matplot. So import seaborn as SES, and we import matplot matplotlib dot by plots as plt. So here we import seaborn and matplot, right, for our visualization. Okay, yeah. Then later we have to create now the f. I want us to rate our data. The f equals to pt dot rate. I want to read the csv file. Okay. Now let's go to our desktop. Let us read concrete data. Okay. Some of us that are also civil engineer, this one also will benefit us. Yeah, concrete data, you paste it, arrow. So if tf is concrete data, so if data we have it is 1030 rows and 9 column. Look at it very well. Okay, so we have read this concrete data, but from the heading, all this cement component, all this I don't like. It is not good. We have to clean them. Okay, so how are we going to do? I'm creating a small code. On this small code, because I do not want us to waste our time, I call df.columns is equals to. So where we see cement, we are going to place cement. Where we see all this, okay, we place only cement. We place blazed funnel where we see all this. We place blaze where we see all that. Place fly ash where we see all this information. Okay, then we run it. We call df. So now if you look at, you see cement blaze funnel, it is now at least good than the first this one. Okay, so we have done that part. Then now let's move on now to check information about this our data. We call gf dot info. Okay, look about the information about our data. So we say gf dot info. We run it. Here about this data set, we have what? We have the class is pandas. We are working on pandas data column total. We have 9 columns. Then cement, the data is 130. So there's no missing data, and we have floats. Number of these are floats. Cement is float, blaze is float, fly ash is float, water, super fertilizer, cost aggregate is only H, that is integer. Concrete composite shell is float. So if you look at it very well, float means that there is point something, point zero, point. And we have here 10 point, all are float. The integer is a round figure, round 28, 28, 270. There is no point. Okay, so these are integers. So we have to move forward to describe our data. So for us to describe this data, df dot to look at the description. We want to look at the description of this data. Df dot describe describe. So now at this point here, look at, we have count. It is 1030, right? These are the number of data. The mean of cement is 281. The mean of blaze funnel is 73.8. The mean of fly ash. So these are the various mean. Then if you look at the standard deviation for cement, these are the for blaze, and what the minimum we have for cement, and also we have this other on percentage. We have 25% of cement blaze, we have 50%, we have 75%, and also we have the maximum of cement, maximum of blaze funnel, maximum of fly ash, water, and so on. Okay, then we move on also to look at null value by doing what we have, df dot is null. Yes, at this point it's null. Yes, for us now to look if really we have missing value. Are we there? Now on cement, everything is false, 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 false. See, where you see true, obviously it means that there's a missing value. If you look at the fly ash, all are false, water false, superplasters are false. When you see true, it's showing that there's a missing value. Let's now put dot sum. Let's sum it to see. Okay, now the sum now give us to see it well, because at that point we were unable to see it because there were some other, look at it very well. Look at there's a point where you have dash dash, so there's a continuation because this data is 130. So that continuation we are unable now to see those dash dash, what is inside. So now for us to do now to see it well, we have to d dot sum, we have to sum. Okay, we have to sum it. So sum now, sum obviously show us that there is no missing, that the missing value here is 0, blaze funnel is 0, fly ash is 0, so there is no missing value. So we look for what, unique value, by doing what, df dot unique, df dot unique. Okay, sorry. Yes. At this point, you see data object has no attribute unique. Oh, we omitted n unique, number of unique. Okay, so we're supposed to fit n here. df dot n unique, then we run it back. So at this point, we have cement, the unique value of cement, we have 280, we have blaze funnel 158, we have fly ash 163. Those are the unique, that they are the same. Then we have water 205, we have superplasticizer, we have cost aggregate, we have fine aggregate. So H has unique of 14, concrete composite stress has unique of 939. So they will move forward also to sort the value. Okay, now we have what, df dot sort value. Df dot sort value, you can say by equals to, yes, we sort by, let's say by cement, by cement. I wanted to know the first 10, df dot sort by cement dot head. Okay, make sure you copy cement at this point. This cement, this capital letter first. Okay, because if it's small letter, it will not go. Then you run it. Yes, so when you run it now at the point of cement, sort by cement, this cement, are we there? Now we say dot head, that will be the first five. If we fit here 10 here, that means we need the first 10. Okay, then obviously if we say okay, the F by cement, then comma, ascending is equals to false. Ascending equals to false. We want it. Ascending equals to false means that what is showing that it starts from the highest to the lowest. Let's fit in the first 20 element here. 20 element so that you understand it very well. Okay, you see 540, 540, 540, that's ascending equals to false. 540 is 525, 525. Obviously showing that we are working in descending order. So let us put ascending equals to true. Ascending equals to true means that what? Now we are working now on ascending order. On an ascending order, we start from the smallest right up to the highest. That is why you see it is 102 cement, because we are working on underword cement. Ascending equals to true, head of 20. So at this point, you look at it very well, starting from 102 right up to, you see, 108, 116, 122, 133. So for ascending equals to true. Okay, so ascending equals to true means that what it work on ascending order. So ascending equals to false means that what you work on descending order. Okay, yes. So then we move forward. Now let's look for the correlation. Df dot correlation. Yeah. So if you look at this column, it's the same thing this way. So it is obvious that cement and cement must have high correlation. Correlation, that's one. Okay, but you have now cement place funnel has -2 correlation. We have cement fly ash. We have cement water. We have cement plasticizer has high correlation 0.09, and so on. Also, you have also for fly ash. So if you look at the point where you have this water, you need to have high correlation, because water is correlating the same with the water, so it must be one, obviously. So definitely, even also for super plasticizer, you have one, because super plasticizer versus super plasticizer is the same thing. Okay, now visualize now this thing. Yes, visualize this thing. Say using seaborn dot heat map gf dot correlation gf dot correlation dot annotation is equals to true. So at this point, we have dot anode equals to true. When we run it, we are going to have what? If you look at, these are the point where this cement, the cement that we say 1. So these are the various correlation, and at this point the top started from 1, 0.8, 0.6, 0.4, 0.2, 0.0004. So from the greatest right up to the lowest. Okay, so look at now at this point here, this center is just once us true, because why? They are correlated with the same figure, like cement versus cement. We have blaze funnel versus blaze funnel. We have water versus water. So all of them happen to be 1. Okay. Then now, if you look at where you have a place where it is a bit darker, it's showing that it has high correlation. Then when you have red, showing that really the correlation is very low. Like for instance, this point, yes, I meant to say that really on this point, the lowest, the darker point, this dark point, it is the lowest correlation, right? And if you look at when it is going ahead, when it's becoming brighter, it's showing that it is having higher correlation. Okay, the dark point are the lowest correlation, and the brighter point are the highest correlation. That is why you see this brighter point as 1 has high correlation more than the other part. This one that is dark like this, it is a minus correlation. It is minus. Okay, let us look at the graph again in order. Yes. Now let's continue on box plot. Let's do df dot box plot. Box plot. Right there. If we look at now the box plots, look at it for cement. Cement we have no outliers. For blaze funnel we have 1 outliers, because immediately after this we have an outlier here. We have fly ash, there's nothing. We have water, there are outliers. We have outlier here. We have this another one here. We have super plasticizer, there's an outlier. We have coarse aggregate, there's no outlier. We have fine aggregate, there's an outlier here. We have ash, we have about 3 outliers. Then we have coarse composite stress, it's an outlier. So in this box plot will tell us the various outliers that we are having. Then look at the fixed size, the figure size on it. Looking at the figure size, if you see on the fixed size, we have what we increase figure size, we increase by 10. Let's say if we fit year 20, we run. Are you seeing? Let's say if we fit here see the figure size keep on reducing. Okay, but if you use 10 as the fixed size, let's say 10, and you run it, you see that it is more transparent and a bit good. So with 10, it is really showing well that really the sizes are showing, and the various outliers are showing well as compared to the other. You look at this one, the outliers are showing well that this one is above the range. Okay, even also for composite strain, the outliers also are showing. So you can manipulate on the figure size. Yes, this x and y coordinate, these are the various coordinates that you can manipulate on under what the box plot. Yeah, guys, let's recap of what we have done. So, from the beginning, what did we do? We started by first, our topic was explorative data analysis in pandas. So, explorative data is for us to look at our data to know the inside the data, what is inside the data, to know the various information in the data. Okay, but for us to do that, we have to import the pandas as PD. Pandas is the one that is giving us the data. We have to import seaborn, okay, to visualize the data. Seaborn and matplot help us to visualize the data. I'll import the data. Then secondly, we have these various information of this nature, so we have to clean them by doing what we call the f.column. Fit now the various elements that we need it to be there. So when we did that, we clean it. That is why we are seeing cement blaze funnel clean more than the other above. So when we did that, our information, we have 130 rows and 9 columns. So we now look at the data information. So now the information about the data showing that what cement we have 130, and there there is no value that is being missing, and float, all are floats except integer of what age is only age that is integer. All our value are float. So we move forward, we describe the value. For the description, it tell us to look what the count, how many of them 130. We look for the mean, we look for the standard deviation, look for the minimum, we look for the 25%, 50%, 75, and the maximum. Okay, like for instance, cement, the maximum is what 540. For blaze furnace, the maximum of blaze furnace is 357. For the material required for fly ash, the maximum is 200. Okay, then now we look now for the null value. Okay, we sum now the null value. Is there any null value? We look at it, so there is no null value. Okay, so cement has no missing value, blaze furnace has there is no missing value. So we move forward of unique. These are, we look for the unique, cement unique 280 and the rest. Then also now we sort the value by cement. So in this sort value, you can still sort value by water, you can sort value by supervisor, by cost aggregate, but I decided to sort the value by cement and ascending equals to true. Ascending equals to true means that what we are working now by ascending order. Ascending order is started from the lowest right up to the highest. If they say ascending order equals to false, it shows that you start from the highest right up to the lowest. So then we continue by what the f dot call. That at this point we are looking for what the correlation in between those various materials. So we happen to see that what if you look at the point of cement and cement, it is one. It is okay that it's obvious that it's supposed to be one because why they correlate in material versus in the same material need to correlate, has a high correlation. If you look at now at the point of cement blaze furnace has minus, that means the correlation here is low. When you see minus, that it is very low. Positive, that it is high. Okay. Then now we happen to visualize it very well using what seaborn SNS. Okay. So now seaborn now give us now the various correlation. Okay, then we move forward on now on the last aspect that I love this one, but this one also shows us on where for us to look at the outliers. So the outliers, now outliers, like let's say like for instance if cement, we know that maximum of cement, the ranges of cement supposed to be 540, but now if we see cement to be ranges of let's say 800, it is a normal, so that is outliers. Okay, that is the mixture. So at this point here, if you look at the outlier, cement has nothing. We have a blaze funnel, you see has outlier of, from here it has one outlier, ranges between about 300 and something, at the range of supposed to end at this point. Okay, then also look at water, has outlier is two. We have outlier, this is the upper and this is the lower. So we have the upper outlier and we have the lower outlier. Okay, So we look at the age. So at the point of the upper outlier, there are three. So and so on. Even also on the aggregate, aggregate also have one outlier. Okay. Yes. So thank you very much. In the next lesson, we are going to continue from there. Yes, so we have come to the end of this lesson. So take care. So don't forget to ring the bell for the upcoming videos. Yes, then you can subscribe so that you follow up on daily basis. Okay, take care. Bye bye.